For decades, our digital lives have been confined to flat screens. But what if our interfaces could break free, floating in three-dimensional space? Industry analysts suggest that the next paradigm shift in human-computer interaction won't be incremental. It will be spatial. This isn't just about larger screens, it's about an entirely new dimension of interaction. We are on the cusp of an era where information doesn't just display, it manifests, a holographic operating system. This radical shift promises a seamless, intuitive, and deeply immersive experience, redefining our relationship with data and technology itself. Our current user interfaces, while highly developed, still largely adhere to a two-dimensional desktop metaphor, a legacy dating back to the 1970s. This limitation, according to experts in cognitive ergonomics, can lead to information overload and reduced efficiency in complex tasks. We scroll, click, and navigate through flattened representations of data, often struggling to visualize hierarchical structures or simultaneous processes. This fundamental constraint restricts our innate human ability to process spatial relationships, creating a bottleneck in how we interact with ever-increasing volumes of digital information. The search for a more natural, intuitive interaction is paramount. Imagine a user interface that floats directly in front of you, a transparent canvas that integrates seamlessly with your environment. This conceptual holographic OS is brought to life with a stunning visual language. Glowing cyan outlines define active windows, while neon orange highlights crucial elements and deep purple accents indicate background processes or AI feedback. Intricate 3D file managers allow for intuitive spatial organization, and media players project immersive content. The background, a softly blurred cyberpunk cityscape, lends a sense of depth and connection to a larger digital world, all rendered in ultra-detailed 8K quality according to concept art specifications. Realizing such a vision involves significant technical hurdles. Researchers indicate that achieving stable, high-fidelity holographic projections requires breakthroughs in several areas. First, projection technology must evolve to render complex 3D objects with sufficient photon density to be visible in various lighting conditions. Second, processing power demands will be exponential. Generating and rendering multiple dynamic, transparent 3D interfaces in real time requires computational capabilities far beyond current consumer hardware. Finally, real-time depth sensing and interaction mapping pose immense challenges for latency and precision, demanding new algorithms and sensor arrays. The holographic operating system offers a revolutionary canvas for data visualization. Instead of flat charts, information manifests as floating, interactive 3D models. Analysts suggest this spatial presentation can significantly enhance comprehension of complex datasets, revealing patterns and correlations that are invisible in 2D. Imagine a financial analyst manipulating a volumetric stock market graph, or a scientist examining a molecule structure in true 3 dimensions. The glowing data charts, animated with high-tech motion graphics in cyan and orange, provide dynamic feedback, allowing users to drill down into specifics with intuitive gestures. Central to this holographic ecosystem is an abstract AI assistant, often manifesting as a deep purple sphere pulsating with subtle cyan and orange energy. This AI is not just a voice, it's a visual, interactive presence. Sources indicate that such an embodied AI can facilitate more natural human-computer communication, offering proactive assistance and intelligent suggestions by visualizing information directly in your workspace. Its abstract form ensures it doesn't mimic human appearance, avoiding the uncanny valley, while its dynamic movements convey processing and responsiveness. This assistant becomes an integral part of the immersive user experience, guiding and augmenting interaction. The debate over primary interaction methods in holographic systems continues among UX researchers. Some advocate for advanced gestural control, citing its intuitive spatial mapping to 3D objects. This approach, they argue, allows for precise manipulation and natural expression, leveraging our inherent understanding of physical space. Others prioritize sophisticated voice commands, emphasizing hands-free operation and accessibility. A hybrid approach, integrating both gesture and voice, is emerging as the most probable path, offering flexibility and catering to diverse user preferences. The challenge lies in creating a seamless transition between these input modalities, ensuring minimal cognitive load. The fundamental advantage of a holographic operating system lies in its embrace of spatial computing. This concept moves beyond mere augmented reality, where digital overlays exist on a real-world view. Instead, the holographic OS creates a fully interactive digital environment that coexists with physical space. Experts suggest this unlocks unprecedented opportunities for workflow optimization, particularly in fields requiring complex visualization like architecture, engineering, and medical imaging. The ability to manipulate 3D models directly in your environment, walk around them, and collaborate on them with others offers an immersive experience unparalleled by any current flat-screen setup. Traditional file systems often bury important documents within nested folders, creating a maze of directories. The holographic OS radically redefines this. Imagine your files and folders existing as transparent, glowing 3D objects, spatially arranged in your workspace. Projects could be grouped into floating clusters, accessible with a simple hand gesture or glance. Researchers propose that this spatial organization taps into our natural memory for locations, making information retrieval significantly faster and more intuitive. The visual hierarchy, enhanced by cyan and neon orange accents, would allow for instant recognition and navigation, turning abstract data into tangible, navigable elements. The future of media consumption extends far beyond a flat screen. With a holographic operating system, media players transform into dynamic, immersive experiences. Videos could be projected onto any surface or float as interactive windows, allowing viewers to walk around virtual environments depicted within the content. Imagine a documentary where you can physically explore ancient ruins, or a sports broadcast where statistics and player data hover around the virtual field. The glowing media players, accented with deep purple for depth and orange for interactive controls, deliver content in a manner that blurs the line between viewer and participant, creating unparalleled engagement. One of the most transformative potentials of holographic operating systems lies in collaborative workspaces. Distributed teams could share a common virtual environment, interacting with the same 3D data visualizations and holographic applications regardless of their physical location. Each participant could have their own custom view, but all contribute to a shared digital reality. Market reports suggest that this could reduce inefficiencies in remote work by replicating the spatial cues and intuitive interactions of in-person collaboration. The ability to point, move, and directly manipulate shared holographic objects fosters a sense of presence and co-creation that 2D video conferencing struggles to provide. As with any advanced technology, a holographic operating system introduces complex security and privacy considerations. The constant projection and interaction with digital elements in physical space raise questions about data leakage and unauthorized access. What measures will be in place to prevent sensitive holographic data from being viewed by unintended observers? Furthermore, the sophisticated tracking required for interaction could lead to unprecedented levels of personal data collection, from gesture patterns to eye movements. Cybersecurity experts emphasize that robust encryption, granular access controls, and transparent privacy policies will be critical for user trust and widespread adoption. Even with compelling benefits, the road to widespread adoption for a holographic operating system will likely be gradual. Historically, major shifts in UI/UX design face initial resistance due to familiarity with existing paradigms and the learning curve associated with new interaction methods. Consumers and enterprises will need robust training programs and intuitive onboarding processes to bridge this gap. Furthermore, the cost of the underlying hardware and infrastructure will initially be a barrier, making early adoption confined to specialized industries or tech enthusiasts. Overcoming these human and economic factors will be as crucial as solving the technical challenges, according to consumer behavior analysts. The formidable computational power required for real-time holographic rendering raises significant questions about energy consumption and sustainability. Projecting and maintaining multiple high-fidelity 3D interfaces concurrently will demand substantial power, potentially increasing the carbon footprint of individual devices and data centers. Researchers are exploring energy-efficient display technologies, such as advanced light field displays and more efficient algorithms for rendering sparse holographic data. Striking a balance between immersive functionality and environmental responsibility will be a critical design consideration, pushing innovation in green computing and sustainable hardware development. Beyond the technicalities, a holographic operating system will undoubtedly reshape societal norms and interactions. The integration of digital interfaces into our physical spaces could blur the lines between reality and virtuality, prompting new discussions on digital etiquette and potential distractions. Ethical frameworks will be necessary to guide the development and deployment of such pervasive technology, particularly concerning user attention, data ownership, and accessibility for all segments of the population. Experts contend that proactive engagement with policymakers and ethicists is vital to ensure this transformative technology benefits humanity equitably, rather than exacerbating existing digital divides or creating new social challenges. The holographic operating system, with its vibrant cyan, neon orange, and deep purple elements floating amidst a blurred cyberpunk cityscape, represents more than just an aesthetic upgrade. It signifies a fundamental reimagining of how we interact with information and each other. While significant technical, economic, and ethical challenges remain, the potential for increased productivity, enhanced creativity, and unparalleled immersion is undeniable. As researchers continue to push the boundaries of projection, processing, and interaction design, the vision of a truly spatial, intuitive, and dynamic user interface moves closer to reality. This is not merely the evolution of UI, it is the dawn of the next era of computing.